I do have a couple of other things I wanted to show you here actually now that once we're done with passive interfaces, and one of them is a bit of an oddity with an OSPF point-to-point link. Now we saw the OSPF point-to-point network type when we did our network, the NBMA network over the Frame Relay Cloud. Remember we made Router 3's interface a point-to-point sub-interface, and we know now that when we put OSPF on that it's going to default to a point-to-point OSPF point-to-point network type. Let's build a pure one though. I've removed OSPF from routers 1 and 3. I left the cost commands, the interface level commands, that kind of thing on. But we're going to build this from scratch, and it's going to be area 0 over the direct link between routers 1 and 3. And this should default to a point-to-point link. Let's see what's going on here. I've already tested the connectivity, as you can see, part of it there anyway. And let's do a router OSPF1 network 172.12.13.0. And since this is our only area right now, we'll make that area 0. Area 0. And we'll start running our neighbor command here in a few seconds. We'll let it cook for a little while. I don't want to hit the elevator button too many times. And you can see we've already got our adjacency, and we got our confirm right after that. Process 1, neighbor on serial 1 from loading to full, loading done. There's something a little odd here though. All of this looks familiar to us except one thing. What in the world is going on with this dash? We see state full, we see neighbor ID, dead time, address, interface. We see everything we expect to see except what we usually see next to the word full. Because what do we usually see there? One of three things, and we've seen all three in our labs. DR, BDR, DR other. So why don't I see anything here if everything else is just fine? Let's run show IP OSPF interface serial 1. I think I've got that here. Yep. Well, we see what we expect to see here. There's state point-to-point, and it is a point-to-point connection. So network type point-to-point. Hello and dead times, everything we expect to see. We see the adjacencies. We're not suppressing hellos. We have our neighbor. Everything looks fine, so right here in the middle of all this, there's no mention of a designated router or a backup designated router. So what's going on here? Well, this can really throw you if you don't know, and you will. This is the normal and expected behavior of an OSPF point-to-point network, because it's configured as point-to-point on both sides, and we can verify that on router 1. Show IP, OSPF interface serial 1. And there we go, network type point-to-point. And what's going on here is that by definition, let's think about this. How many hosts do we have on a pure point-to-point link? We have 2, right? One at each end. That's a point-to-point connection. And that's all we have. We can't possibly have a third one there in the middle, because then it wouldn't really be a point-to-point network. So what happens here with OSPF is looking out for us in a way, and it's cutting back on a little bit of overhead, because there's no reason to elect a designated router and a backup designated router for a segment that can only have 2 hosts on it to begin with. Because let's take that a little further. What's the main thing that a designated router does for a segment? It notifies everybody else on the segment of a change that it hears about from another router on that segment. Well, if we only have 2 routers on the segment, and router A tells router B about a network change, who's left to tell on that segment? Nobody, literally nobody. So there's no reason to have the overhead of a designated router and backup designated router election if you don't really need one. So on a point-to-point network in OSPF, as we've seen here live, you will not have a DR and you will not have a BDR. So when you run show IP OSPF neighbor and you see this dash here, that's why you're seeing it. We don't need a DR or a BDR. Now, we don't get into this next kind of OSPF network that I'm going to mention in the CCNA, but I want you to know about it. There is a point-to-multipoint network with OSPF as well, and OSPF just considers that to be a collection of point-to-point links, so you're not going to see DRs or BDRs there either. Again, that's in your NP studies. You might not even see it there. But the key here is with a point-to-point network, when it's configured as point-to-point on both ends, you're not going to have a DR or BDR election on that particular segment. There's one oddity I want you to see about a broadcast network as well. I'm going to run that one for you next, and then we're going to take a few minutes and look at route redistribution. So I'll see you in the next video, and we'll see what's going on in this broadcast segment.